What's going on, everybody? Today in this video, we're going to be doing some Civil FE exam review, and we're going to be focusing specifically on mechanics of materials. So I do have a practice problem for you all today, and I want to go ahead and get straight into the content. So before I get started, I like to talk about the subtopics that we're actually covering from the FE manual. They literally tell us what they're going to be testing us on, and so I want to share that with you now. Okay. So we've already done shear and moment diagrams. If you have not watched that video, be sure to check it out. Today, we're going to be looking at stresses and strains. And so if you are not subscribed to the channel, make sure you do so. I literally go over every subtopic that is going to be covered on your Civil FE exam. And so I do some practice problems. And so if you feel like you need time to study, like after work, before work, you can literally sit down, go through some of the problems that I share with you, and that will give you somewhat of a head start as you are studying for this exam. All right, so our practice problem today, it says a 2-meter long steel rod has a cross-sectional area of 0.30 centimeters squared. The rod is a part of a vertical support that holds a heavy 550 kilogram platform that hangs attached to the rod's lower end. Okay. Ignore the weight of the rod. What is the tensile stress in the rod and the elongation of the rod under the stress? Okay. So if you can kind of picture this, so I'll just draw out the straight line. So imagine this being, trying to draw straight, get as straight as I can for you. Imagine that being like your rod, and then basically you have this vertical. So then we have this like 550 kilogram, mass applied to this rod, right? So how would we start this problem? Well, what is it asking us for? It was asking us for the tensile stress in the rod. So I know that I'm going to need to find some sort of stress and elongation. So will I need to use my FE manual for this problem? Yes, I will. I will need to find formulas that have tensile stress in it and elongation. Okay, so I have already done some of that work for you. We have here our tensile stress, which is just P over A, or the loading divided by the cross-sectional area. Okay, and our elongation of the rod is going to be this kind of deformation symbol. So, and that is equal to PL over AE. All right, so where did I get this from? Just quickly show you. So I normally like to type in, I like to go to the mechanics of materials section, really. But we'll just type in, I'll just do a control F and do stresses. Stress. Okay. Looks like we got we got there. Maybe. Nope. Thought we did. It is somewhere in here. Okay, so normally in mechanics and materials, that's where you kind of get to what you need, because that's the topic that we're currently in. All right, and boom. Uniaxial loading and deformation. This is where I pulled this information from. So really important that you're able to navigate your manual, right? All right. So first we'll start out with finding our stress, which is just P over A. So what is P? We don't need our text to be that big. P divided by A is equal to what? All right, so P is going to be you probably can't see the problem now. There we go. So P is the weight. So we know we have a mass of 550 kilograms. So we'll start there. So 550 kg. So how do we get a weight, right? If we're given a mass, we have to multiply that mass times gravity to give us our weight. So what is gravity in this case? 9.8 meters per second squared, right? And then this all over A, right? So what is our our area? And that's what's our cross-sectional area? Well, they say it's 0.30 centimeters, right? Centimeters squared. Okay. But we cannot just use this 0.30 centimeters squared. We need to convert that to meters squared so that our units will cancel. So I'm just going to drag this over here. And we'll say equals. How much is 1? So we'll just say 1 meter square. How much is 1 centimeter compared to 1 meter? So we know that 100 centimeters is equal to 1 meter. Right? So if I need to square this to cancel units, and I kind of did that a little fast, but hopefully you know how to do this. It's just basically unit conversions. That means I need to square both so that my units will cancel and I get it in meters squared. So, all right. So that's going to give us what? Looks like 0.30. One, two, three, four, five. So it looks like gives me 3 times 10 to the -5 meters squared. That's what it looks like it gives me. So I am just going to, or can I copy this? Still getting used to my tools, so we'll see if I can control. I can. Very nice. Okay. So now we know that our units line up, and this should give us an answer in pascals. 1 kilogram times a meter per second squared gives us a pascal, I believe. So, all right, let's see what we get here. 550. All right. So I get 1, 2, 3, 4, 5, 6. Okay. And so I'm just going to say this is 1.8, round it up, times 10 to the 8th pascals, and that's my stress. Okay. So we got the first part. What is the tensile stress in the rod? We got that. What is now the elongation under the stress? So, elongation, I know, is going to be equal to PL over AE. So we have P over A already. We just need L over E. All right. So let's look at this. Let's go ahead and grab this. So this is P over A. All right. What's our L? 2 meters. So $2 meters. I'll just say times 2 meters. What is our, so we got P, we got P over A, we have L. What is our E? Well, I believe that our E is just our modulus of elasticity of steel. And so where did I get? So I went ahead and found it for you. Is 200 GPa or 200 gigapascals. We need to convert those units. All right. So where did I find that first and foremost? So if you just type in, you go to your FE manual and then you type in steel. It comes up as the first thing as material properties. And I looked under modulus of elasticity and it gives it to us in I guess mega PSI. But we don't need it in those units. We need it in gigapascals or in pascals. So gives us that. What's a giga? Because I don't know. So I do know that for any unit conversion that you don't know, you can always go to it's like the first or second page, the manual. I thought it was the first or second page. It's actually like, yeah. So it's page number 1. And I see giga. So that means it's times 10 to the 9. Okay. All right. So let's just do some simple math here. 200 GPa. And I need it equals 1 times 10 to the 9 PA. And this will give us, and I don't need to have equals, it needs to just be multiplied by, so, and this is 1. So hopefully this unit conversion makes some sense in your mind. It's kind of confusing with this equals, but my GPAs do actually cancel, and I am left with, so now it's time to put my equals. Don't want this in red. I think it should be 200 times e to the 9. So it's 2 times 10 to the 11. And this is in PA. All right, so, all right, now we have our PA value, which should have been the last thing that we needed. All right. So let's see how many meters we're left with. All right, so hopefully you see what I've done here. I've just basically done my deformation, which is equal to PLAE. My P over A, I went ahead and found that, which is 1.8 times 10 to the 8th pascals. That's my P over A. My L is the length of the rod, which they tell us is 2 meters. So 2 meters. And then the only thing that's left in this equation is E, which is your modulus of elasticity, which we got to be 2 times 10 to the 11th PA. So my PAs cancel, and I should just be left. Let's do a blue. Let's do a blue for this. My PAs should cancel, and I should only be left with meters. Okay. Really important that you make sure that you are converting your units and that your units are canceling. Sometimes you're not just going to be able to use what they give you. You're going to have to transform it into the equation so that your answer makes sense. All right. This is the top skill that you need to have down. Okay. So let's see here. 1.8 e to the 8. Let's see what it gives me here. Times 2 divided by 2 e to the 11. All right, so I am getting equals 0.0018 meters. Hopefully this made sense. We got a small amount of elongation happening because of this 550 kilogram mass that was acting on our rod. We don't want that thing elongating a ton, because that just means that mass is too much for the rod, right? So hopefully this was helpful for you. Let's take a look at what our next topic will be. Looks like we will be taking a deeper look into deformations. I'm going to try to throw in maybe a thermal deformation practice problem and maybe a few others, so that you have a mix of what they may throw at you on the exam. If this was helpful and this practice problem was helpful, you're not going to be able to get all of the practice that you need just from this channel. I do and am actively trying to make a ton of practice problem videos for you. But if you want a guide that has multiple practice problems, multiple videos that clearly explain each of these different subtopics that I'm going through, then definitely check out the free resource that I have in the description box down below. It has two of the main topics. I believe it's dynamics and mechanics of materials, that it gives you videos, it gives you practice problem sets, and then it gives you practice quizzes, where that is going to help you master what's going to be on this exam. And it tries to encourage you to get better with time and getting faster with the problems, right? I went through this very slowly. On the test, you're going to have to know what to do and know what to do very, very fast. And then if you want all of the topics, right, all, I believe it's 14. Yep. All the way down to construction engineering. It's all 14 topics. Then you're going to want to look at the full study guide. It is an investment, but it will save you tons of time and headache having to retake your exam multiple times because you don't know what is going to be on the exam. This study guide will fully prepare you for it, and other students are seeing the benefits of it. If you're a person who has been out of school for a little while and a lot of this material is kind of foggy in your brain, had a guy that had been out of school for 5 years. I had even another guy, he had been taking it for, I think it was he had taken the exam 5 times before he got access to that full self-study guide that allowed him to finally get the concepts that he needed in the time that he needed to be able to get the problems done. So just a little pointers here and there. Also, if you're wanting to work with someone, you're wanting to skip that process of trying to figure out what in the world you need to be studying, kind of coming up with a game plan, having someone share with you some of your weaknesses, some of your strengths, and how you can really fast forward and fast track the amount of time that it takes you to pass your exam. What you can do is check out my website. You will be able to fill out a form and book a call with me to see if you would be a good fit to work with me one-on-one. I am looking to bring on maybe 3 more. We're kind of have a few students that I'm working with, so I don't want to be too jam-packed, but would like to bring maybe 3 more on, create some more success stories. So if this is you, make sure you check out my website down in the description box below. Looking forward to working with you, and I really appreciate you all for tuning into these videos. It's really exciting. Right now, I think we're at 900 and something subscribers. So we are getting to that 1,000 subscriber mark, which is going to be huge. It means I'm making an impact and am helping at least 1,000 people to pass their civil FE exam. And, this is crazy. Never would have thought this would be happening. So again, thanks for watching this video, and I will see you all in the next one. Peace.